Cool. 763 partition labels, medium. A string S of lowercase letters is given. We want to partition the string into as many parts as possible so that each letter appears in at most one part, and return a list of integers representing the size of these parts. As many parts as possible. Let me look at the example. Alpha 987. Each letter. Okay. But you wanted to have the most parts as possible. So I think actually this seems like it would be a good candidate for greedy. I think I get this question a lot where when do you decide to choose greedy and when you choose or decide to choose to go dynamic programming. And I think my intuition just from years of kind of getting kind of what do we call it? I don't know, conned, if you will, convinced by to like they always try to get you to do like a lot of dynamic program prompts. They always try to get you to go greedy, and then you find out the hard way that it's not greedy. So after you do that many times, your intuition is no longer greedy, or that like you have to prove to yourself that it's greedy before you actually start on the greedy. But in this case, it seems like that would be the case because for a given letter, the most you want to like in order to have the most parts, that letter would have to appear in the fewest on one, but the shortest string because the shortest strings, and it has to be true. Right? There's no way to subdivide that part. So that's why I'm leaning toward greedy. But let me also double check. Well, n is 500, so I think that's the only thing that maybe is not, because it could still be dynamic programming. So I don't know. I think I always get a little unconvinced by my greedy proofs, but because in this case, for example, you have D who, yeah. So I think maybe I'll just do dynamic programming. Yeah. Hey JJ 9899897. I'll do it next, as long as it's reasonable difficulty or whatever, or I'll do it tonight. Yeah, let me think also about dynamic programming solution, right? Well, how would a dynamic programming solution work? In this case, you have a function of a string, and that divides you into three things. As many parts as possible. Yeah, I mean, I still think it's probably some weird greedy thing where, yeah, you just take the beginning and then you kind of take the, you take the last A in this case, and then you go through all of them inside iteratively, and then add them as necessary to kind of almost like a weird, like a minimum spanning tree algorithm type thing, where like, okay, now you have to, for this set of tasks or whatever you want to call them, you've done them, but within those they I guess also like a topological sort maybe kind of algorithm. I mean, I'm not saying that those are the algorithms that solves it, but like that's the kind of thinking that's forming my mind when I think about this. So I'm going to try to do that, if that makes sense. I think it's just kind of keep on adding letters so that it's consistent, and then once you're done chopping off, you're good. And since n is 500, you could do one an n square algorithm in this way. So you look at, oh, if the first x characters good, then something like that. Okay, but I could also, yeah, okay. Let me try to code something up, and then maybe I could explain it better after I code it up, so that I could see kind of where the edge cases are. Because I think that's how I think about it a little bit. Though for an interview, that's a sketchy view to take, maybe. Yeah, okay. How do I do it? So now we're adding this letter. Okay, so yes, verbose as possible, just to and now we want the last instance of this letter. Okay, so is it like the last index of in Python? Sorry, I'm just Googling it right now. I actually don't mind Googling on the stream, but Google autocomplete always, I don't know, it's a little sketchy, so that's the part why I'm Googling a little off screen. Is it like a last index of type thing? I mean, I could just implement it, but I just want to be lazy. All fine? Huh. Okay, I mean, you learn something new, so I'm learning something new. Okay, so that means now now we have a string. Our current string is between current index and last index. This is I sometimes write comments to kind of remind myself where I'm at, but maybe I don't even need this. Let's do this for now, because the I is a little awkward. And now what we want to do, we're given the string, we want to see that all the characters within it are, yeah, maybe not. How do I do that? Okay. Should be another outro. Oh, well done. Not done. Don't want to. So what I want to do is something like FI. I always have to double check that. Off by one, though I guess I've been doing enough to use that I practice. Maybe I keep a set actually. Yeah. Is it insert? Maybe it's insert. I always forget it. Sometimes I always forget what's insert and what's add with certain things. But if finished. That's just greater than last index, then well, last index should equal to next, and then you break, and then done is equal to false, and you break, and then you kind of slowly grow out that way, and hopefully it doesn't break. And then now current index is equal to last index plus 1. So okay, so our last condition is actually last, and maybe doesn't matter. something like that. Or could be equal to maybe actually, but. Maybe off by 1, but we'll see from the tests. I'm always I say a lot about I talk a lot about off by 1 because that's just something that I through experience, just something that I'm not as mindful about, but definitely maybe you're better at it, then you don't have to worry about it as much. Oh, oops. This is a while look the other way. Okay, is it add? It's weird, right? Because maybe current index. We set it to last index, so I don't know if that matters. Again, maybe there's an off by 1. Okay, so this seems right, except for that it's off by 1 again, because the length of it is off by that, but I think this is the part generally I would, especially if I was an interviewer, I would try to think of different more test cases, and maybe I could do at least one more, because this should encompass the entire string, so this should just be 27 or 25 or something. Yeah. Yeah, because I was looking at this. But okay, and also I would just generally like do more test cases and we talk about it the interview and something like that. But but online I'm a little lazy, so oh, it has to be at least one. I think I always do the empty case or empty string case because that's something that I always forget about. Let's see if that works. Okay, cool. So greedy does work, which to be honest, when it comes to greedy, I'm not always confident about my solutions until I get that submit. Very often I will. Yeah, wait. Sorry, I'll answer your question in a second. So, the Hikamo, I don't know if I'm saying it right, but yeah, very often for greedy cases, I'm not confident about it because you base your greedy solution on a set of assumptions that either you prove to yourself mathematically, which is fine, or like you just have an intuition, which is sometimes, and very often they make it so that your example cases, the example inputs, that is, they make it so that it works for greedy, but then deep into the test cases, there's one that's where greedy doesn't work, or it's off by 1 or something like that, and you're like, I should have known better. So that's why I'm always like a little, I don't know, just not confident about it. And in this case, I guess we have a reasonable intuition, but I'm always a little worried. And to that answer, that's also why, unless like a problem is like standard-ish, I want to say, or like proofs to a standard, like Dijkstra's algorithm with graph algorithms, like if you could draw this to a, if you could what's it called? I forget the mathematical lingo, but if you transform this to like a Dijkstra algorithm or something like that, then you could prove that greedy works, and that's how I would think about certain type of problems. But other than that, it's not my set of problems that I like to do because it forces someone like an interviewee. If I was an interviewer, if I ask this question, then it forces them to kind of prove that it's greedy and so forth, and that's something that's very hard to find like mathematical rigor for, and certain people have different preferences. I don't know about. As an interviewee, I also have those kind of uncertainty as well, as you kind of see with me doing it live here. So I don't know, but in terms of difficulty, I guess once you kind of get it down, the coding is actually I think it's interesting enough that it's interesting, and there's definitely a lot of edge cases and weird things that you can go wrong in. So in that sense, it's a good programming challenge. Maybe not, like maybe it's in the right difficulty. So I dig it, but Yeah, I don't know. And maybe there's different ways to do it and take advantage of the fact that the alphabet's only 26 letters or something like that. Um, but I think I had an okay solution. I think looking back as a post-mortem code review type thing, I could actually relatively, I don't always do this on stream actually, but I actually relatively named the variables pretty okay. I mean, I could probably um, abstract some of these out to like a helper function for sure, but maybe it's not too bad. I mean, I could still, and if I was an interviewer, I definitely would have, I would still say that I should, but yeah, I definitely would clean this up a little bit. But otherwise, I think I'm okay with this problem. Yeah, this would be a good phone interview question. I think, I mean, I could definitely see it asked, like as someone who wants to get a job and I'm interviewing as an interviewee, then I could definitely see it being asked. As I said before, I mean, it's not my cup of tea to ask because I like to, I just don't like to ask greedy solutions because I feel like it trips people up in a weird way, in the sense that it almost kind of have a weird incentive unless you're really really good at math, which is that's another story. But like it almost because people who study algorithms and stuff like that, they might actually get the problem slower than people who are just like a little very self-confident, say, and they're like, oh, it must be greedy, and that's their only intuition because they don't have uh, maybe different tools or something like that to solve this problem. They're like, oh, I only think of the greedy solution because that's the only thing I know, right? And in that way, it kind of incentivizes things to be like a little weird incentive kind of thing. I don't know if that makes sense. I don't know if describing it right, but in that way, that's why I don't like giving it. But that's just my kind of philosophy. I think definitely a lot of people. I mean, I think it is on a white difficulty. I solved it ish in. I mean, I talked a little bit a lot. So I solved in 15 minutes, which I think, which means if this is a normal 45-minute interview, then you could definitely. I would definitely see this on a problem, depending on how much time they allocate to the programming part. Because on the phone screen, depending on your interviewer, some people have different philosophies about phone screens. But definitely, in my experience, and I haven't done phone screens in a while, to be honest. But I've seen people done like maybe like 10 minutes talking about your past. You know, maybe like another 10 to 15 minutes, just a breath of kind of trivia, but just kind of see like what you know, like a quick, what's it, like rapid fire type questionnaires. And then in that sense, you have probably like 20 minutes to 30 minutes to solve this, which I think is enough given that you, like what we said earlier about greedy solutions, like if you're confident, then you could definitely code this up in that time. But that's the problem with greedy problems for me anyway, is that it's not always clear that greedy is correct. Maybe I need practice on that though, so maybe that's just me. Um, cool. Yeah, so I think that's all I have for this problem. Let me know if y'all have